Now see here, this is the next chapter, that is chapter 2, and here we are going to study about electrostatic potential and capacitance. We have already studied about electric field and electrostatic force and electric flux in the previous chapter. So in this chapter, first topic is electrostatic potential energy. So let us understand the concept of electrostatic potential energy. See here, suppose you have taken the charge q here, this is capital Q, which is greater than 0. It means that is a positive charge. It has got electric field around it. Suppose any test charge is placed at point, this point is here, and that test charge is suppose q. This q is known as test charge. This charge has got a small magnitude, so it does not affect the configuration of the source charge capital Q here. This charge experiences electrostatic force to this side, that is Fe, and this is repulsive force. Now, suppose this charge is moved from this point to this point. Suppose this charge is moved from this point to this point towards capital Q and by a small distance dr. So, when we move this charge from this point to this by a small distance dr against electrostatic force, then the work done by external force can be written dw is equal to F external dot dr. Now, suppose this charge is brought from any point A to any other point B in the electric field. Then we can write the total work done in taking the charge from A to B. So, total work done by external force can be written A to B F external dot here dr, and this work done is actually equal to negative of the work done by electrostatic force. So, now this work done is stored in the form of energy, and this energy is known as electrostatic potential energy. So, electrostatic potential energy difference between any two points A and B in the electric field is defined as the minimum work done required to be done in moving the test charge q from point A to B without any acceleration. So, now when charge is at A, it has got potential energy suppose UA, and when the charge is at B here, it has got potential energy UB. So, now when the charge is brought from A to B, so work done can be written UB minus UA. So, this is the difference between the potential energies of the charge at the point A and B here. Now, see here, this work done is independent of the path followed, it just depends on the final and initial position of the charge. That means, also here electrostatic force is conservative in nature like a gravitational force. Suppose the point A lies at infinity, then we can take UA is equal to 0, and the charge is brought from infinity to the point B, then we can write W infinity to B is equal to UB minus 0. So, now here we can define here the potential energy of the charge at any point B is equal to the amount of work done required to bring the charge from infinity to this point B without any acceleration.